one thing is, at the anode, we have our reducing agent. What is the reducing agent? Copper. So copper is a reducing agent. It's going to supply the electrons. So we have copper 2 plus 2 electrons. This is called the reduction half reaction or the oxidation half reaction. So the reducing agent, is this a reduction half reaction or oxidation half reaction?
Oxidation.
It's oxidation, so it's very confusing. The reducing agent undergoes oxidation. It's because the oxidizing agent takes the electrons from the copper. So the copper, yeah, this is good, is losing, and then you show the copper going to copper 2 plus, but you should also show, the 2 electrons going up into the circuit. This would be the circuit here. So you can go through the wire. And what's pulling it through the wire? The oxidizing agent. What is the oxidizing agent? Oxidizing agent is silver nitrate. And what is it? Is it the silver or the nitrate or both?
Silver.
It's the silver. How come? Silver's the thirstiest? What's the thirstiest of elements or compounds? In other words, what's the strongest oxidizer you can think of? Fluorine. That's good. So yeah, fluorine should be at, well, we don't have any fluorine there. We got silver ions, so maybe the silver ions are the thirstiest, you'd say? That's pretty good. Thirsty for electrons. But it depends, it depends on how familiar are you with this chart? It's not like you have to have this chart memorized, but once in a while if you look at it and then see, yeah, silver ions are pretty thirsty. Fluorine's up there. Silver is what we call a strong oxidizer. We have to watch out with that in the lab because it turns everything black. Silver ions. But, and what about nitrate? Tell me some chemical properties of nitrate. Well, what are the chemical properties we consider? Nitrate, if you're thinking about the chemical properties of nitrate, you'd look at metathesis. Pretty much metathesis is nothing because nitrate precipitates out with nothing. And so nitrates are pretty unreactive in metathesis. How about acid-base? Are nitrates very reactive in acid-base reactions? Well, nitrate is it's a base, right? Is it a very reactive base? No. Like chloride. I talked about chloride. Chloride's a base here, but if you're in the supermarket and you're looking at a pound of salt, salt's pretty cheap, less than $1, right? For a pound of salt, sodium chloride, versus some antacid. Antacid's expensive. You buy a thing of Tums, it's pretty expensive. Tums, Rolates, milk of magnesia, all those are expensive. So can you go with the low budget solution? Just buy table salt as an antacid. Is that going to work? Will it neutralize stomach acid, table salt? No, because we know that these bases are too weak. So nitrate, nothing interesting, right? No metathesis, no acid base, so no nothing, right? No nothing, is that right? For nitrate? Or is there something? Are we missing a reaction type? Redox. So what do you know about nitrate and redox? You guys remember the Grand Camp? You guys remember the Grand? Does that ring a bell? The Grand Camp freighter, Texas City. Does that ring a bell? Yeah, Texas City. I remember 600 people died. Texas City. Actually, there's a more recent one, but not as many people died. That was in China in 2015. You hear about this one? Let's see if I have it. The Tianjin explosion.
What was it that exploded?
Industry.
Okay, so I need to go back. Have you seen this one? This is the this is an eyewitness one. This has been censored though. The language was. It's a skyscraper there, in the shadow. Can you believe that?
That's terrible.
Where are they?
Yeah, let's go now. Yeah, just stay there for a good 30 seconds. Let's go. Oh my god. What was he saying? That was so all the employees' cars look the same.
A bunch of shipping containers. It's crazy, isn't it? All right. What's that? This is nitrate. There's ammonium nitrate currently. This is like the same as Oklahoma City. That's because the chemical property of nitrate, you know, nothing for, pretty much nothing for metathesis, nothing for acid base, but something for redox. You know what chemical property really stands out is that nitrate is a powerful oxidizer. In fact, what would be a more powerful oxidizer? Silver ions or nitrate? Nitrate's more powerful. And so, are you sure that silver ions are the oxidizer here? What has a stronger pull? What's thirstier for electrons? Nitrate's thirstier for electrons, right? Because nitrate's more powerful. And rather than forming silver metal, you know, this electrode should grow. Silver metal being deposited on here. This electrode is going to shrink because the copper is being attached, forming copper 2 ions. But as this one grows, rather than forming silver metal, we should be forming nitrogen monoxide gas, toxic gas, right? In fact, the nitrate should be pulling the electrons off and generating NO gas, right? Yeah? No. There's something wrong with that. Actually, you had it right. It is the silver ions. It is the silver ions that are going to be pulling the electrons through. Why is that? Can somebody remind me why it's the silver ions? Maybe you can't, because maybe it wasn't a very good analogy. Whatever. I was talking about making cookies. Does anybody remember that? The flour and the sugar? Okay, that is not a good one. This is why you got to keep, rather than listening to mine, which are, might be totally worthless, as far as analogies go, maybe you should make your own, because if you make your own, even if they're bad, you remember them. Like mine, it could be bad, but I still remember it. I remember it very well because I made it. And so if you make your own, then it's a lot better. Mine was like, huh?
Wasn't it like you didn't have no sugar?
Right. Okay, David remembers. But they would taste horrible, but it's not really going to work out, right? Yeah, so to use nitrate, it was the 4 cups of flour and 1 cup of sugar. Do you remember that? 4 cups of flour, 1 cup of sugar. This is what it was. When we have nitrate, and we want to make something, making something, we need 1 cup of sugar, the nitrate, and 4 cups of flour. We need the H+. If we don't have the H+, let's say, well, I don't have the flour, I'm just going to make sugar cookies. Sugar, just 1 cup of sugar. Let me my sugar cookie. Is that going to work? No. It's not going to work. If you're missing this ingredient, are you going to make the products? In other words, we just did limiting reactant. What happens if one reactant, there's no reactant? This is going to be the limiting reactant because we have 0 of it. Are we going to get any reaction? We're not going to get any reaction. And so this is going back to here. What are we missing here? We got the nitrate, but we're missing something. We're missing the hydrogen ion. We don't have the acid. We need the acid, otherwise it's not going to work. And therefore, its ranking is going to go way down. Does anybody remember the pattern? There was like plus 2 H pluses, plus 4 H pluses, plus H plus, plus H plus, plus H plus. What do all the plus H pluses have in common? I mentioned this in class, but if the thing is, if I tell you what the pattern is, it's not the same thing, because I can tell you what the pattern is. It goes in one ear, out the other. It never, gets stuck in your brain. But if you find the pattern yourself, then it sticks. Do you know what the pattern is? Do you see the H plus? What do all the ones that have plus H plus have in common? See, and then when you see that pattern, then you know, okay. Yeah, it makes water. All of them make water. And this is something I mentioned, I don't know how many months ago, but I did say that. The Chem 4, I'll just tell you what the pattern is. I didn't tell you all the patterns in this, but just one of them. And so, this is critical, because otherwise we aren't going to make H+. If we don't make H+, what are we going to make? We're just going to make oxide. Is oxide very stable? No. And so it's key. If we make oxide, it's going to be a lot less stable. Therefore, its ranking is going to drop. It's not going to be as powerful. And so it is correct that silver ion does do the oxidizing here, but we could have just as easily said nitrate does, because nitrate's a more powerful oxidizer. We're just missing the 4 cups of flour in this particular reaction. Does that make sense? And so there are different levels. I was talking about this earlier in the morning, but a lot of people have asked me in the past, do I need to memorize this? No, of course you don't need to memorize this. Sorry. And there's no purpose in memorizing this. I mean, why would you want to memorize such a big chart like this? You know. But the problem is that some people say, "Oh, good, I don't have to memorize it. Then I'm never going to look at it again." They look at it once and that's it. And that's also very bad. You know, you don't. What you want to do is you want to once in a while look at this because you know you have different levels, and so one level is somebody can use this chart. You can use that chart. That's good. But that's not going to take you. That might take you to the base A. You know, because what I found as a student, when I was a student at UCLA, I could get an A in the class just by remembering. If I could remember everything that was said, then I could get like just the cutoff A, and it was kind of not too bad. However, if you want the top grade in the class, then you got to do more, you know, and the more is this. You know, you might be given an oxidizing agent that doesn't even appear on this chart. What do you do then? Can you position it? You know, would you be able to position it somewhere in here? Or you might be given a reducing agent that's not on the chart. Could you kind of figure out where it might be? You know, so that would be taking it to a different level. That would be having to have a deeper understanding of things. And so what I found as a student is that, one, you could get an A without having a deep understanding. It's just remembering and regurgitating. But if you want the top grade, then you're going to have to do more. And that more is, well, how do you get that more? The more is you want to review this chart once in a while and see if you can see the pattern. You know, what do all strong oxidizers have in common? Well, do you see? They're all thirsty for electrons. What makes them thirsty for electrons? Well, it's different things that make them thirsty for electrons, and then you can see those patterns. And so, so a challenge question might be something like this: why isn't nitrate? You know, nitrate's higher up on the chart. Why isn't nitrate the oxidizer here?
It's because it can't attract the same charge.
You might say, okay, nitrate's negative, so negative and negative repel each other. Negative and negative repel each other. That's Coulomb's law. That's a law, basic law of physics. If it's a basic law of physics, then why is this like this? This is why people, you know, people who don't really look at the chart might not see there's a contradiction here, you know, some kind of paradox. And what is that? This is a 2 negative ion. There's a 2 negative ion. What's this trying to attract electrons for? You know, if it's negative, and not only just -1, it's -2, then how the heck is this going to pull electrons? Is that thirsty? It seems like it's not thirsty. It seems like it's overflowing with electrons, right? And so we did talk about it before. Does anybody remember? Why? Nitrate? I did mention this because ammonium, you know, ammonium's a bit backwards. You know, we talked about ammonium nitrate when we were talking about the grand Chem. Ammonium, electron poor or electron rich? A lot of people say electron poor. Positive charge wants negative charge. Electron poor. Nitrate, electron poor, electron rich. A lot of people will say electron rich. Negative charge wants positive charge. But that's wrong. That's wrong. Does anybody remember why nitrate is not electron rich, but electron poor? Because of the charge of nitrogen, and where this negative charge originates. That negative charge originates from the 3 oxygens. The 3 oxygens are 2-. Are those happy as is or rich? Oxygen with a 2- is happy as is. Nitrogen is what? +5. Have you ever heard of a +5 ion? No. And so what some people do is rather than write +5, they'll use Roman numeral to say it's in an oxidation state, +5. Like this. That's what you'll see. And the reason this negative charge results is not because there's an extra electron hanging around. It's an imbalance of charge. The imbalance of charge is you got -6 from the 3 oxygens plus 5 for him here, and that results in a -1 imbalance in charge. But that -1 imbalance in charge comes from the oxygens. The oxygens are very happy with a -2 charge, so they don't want to lose those electrons. It's not electron rich. It's just happy as is. But the nitrogen's not so happy because have you heard of a +5? No. +5 is very high charge, making nitrate in particular very electron poor, making it a strong oxidizer. Nitrate's a very strong oxidizer. However, we need that H+ though, and so in this case we don't have any H+, therefore it's going to drop it in rank, and this looks good. So silver ions will be taking the electron to form silver metal, silver solid. I didn't realize, but this morning I had somebody write it on the board as well, and there's still some people struggling with the charges. Like for example, SO4 minus. Does that look right to you? Or Ag2 plus? If either of these look like something you could have written, then do a little bit more with it. Remember, silver. This is very common. People often write silver as a +2 in Chem 4. In Chem 1A, you're going to run into some serious trouble if you do that. But in Chem 4, it seems to happen quite a lot. But if you can remember the periodic table, let's take a look at the periodic table here. If you can remember the periodic table, then you'll remember where silver lies in the periodic table. Where does silver lie in the periodic table? What group is it in? What group is silver in the periodic table? Silver is in group 11 or group 1b. Where does group 1b come from? Why 1b? Because we have 1a. 1a is over here. Why do we need a 1b when we have 1a? Does anybody know the origin of this 1b? What that means? It means that it has one valence electron. Well, how does silver have one valence electron? Because when I think about silver, what's the electron configuration for silver? Well, it's argon, 4s2, 3d9. Silver doesn't have one valence electron. Silver has 2 valence electrons. Is that right? No. Because this is the wrong electron configuration. Tell me what the correct electron configuration for silver is. Argon. 4s1. 3d10. Silver's an exception. Why? Because it's just one electron short of filling the d sublevel. And so that gives it one valence electron. Well, if it loses that one valence electron, then it's going to form silver plus with the electron configuration of argon, 3d10. And so silver only forms one charge, and that's +1. Unfortunately, not everything works out so nicely, because copper forms +1 and +2. So +2 copper is 3d9. And gold forms +1 and +3 is d8. And so copper and gold kind of bucket, but silver is good. Same thing with cadmium. What group is cadmium in? Group 2b. Do you know what the charge on cadmium ion is? It's always +2, and zinc is always +2. So does everybody remember this fixed charge? This is the fixed charge elbow. Some people forgot this morning. And the rest are variable charge. And so if we use little patterns like that to help memorize, that's good. If not, let's just do whatever, flashcards or whatever it takes to make sure you get it right. Because on the final exam, we're going to have some chemical reactions. And if you can't get the formula correct, like for example, today somebody wrote this formula, KSO4. Does that look right to you? No, so if this formula is wrong, that's it. You get no credit for that. And it's pretty much no credit for the whole problem. And so just do a little bit of review if it was still a little bit fuzzy. And for example, borate. Does everybody remember borate? What's borate? VO3 is correct. VO3, 3 minus. Group 3, 3, 3, 3, 3. Carbonate? Yeah, 3, 2. Nitrate? 3, 1. So 3, 3, 3, 2, 3, 1, 3, 1, 3, 1, 3, 1, 3, 1. You guys remember the pattern? Sulfate, I wasn't, this threw me off guard. SO4 1 minus totally threw me off guard because I remember silicate. What is silicate? Silicate is it's in group number 4, so it's a 4 minus or 4 oxygens or what? SiO4 charge 4 minus. It's a 4. Phosphate PO 4 3. So 4 3 4 2. So sulfate's a 4 2. They wrote a 4 1. So I was a little bit surprised about that. Hopefully, get it cleared up by the final. You need it cleared up by the final. If the charges and the formulas are fuzzy, get it cleared up by the final. But anyway, let's go back to this, what we're talking about here. We're doing reviewing now.
Oh, now we're starting reviewing now.
Yeah, we started reviewing yesterday, and we're continuing to review right now.
But, like, we're not going to
We don't have enough time to review the entire course.
But we're not learning anything new.
Actually, one last thing new is skeleton redox. We have to talk about that. Skeleton redox, and then I might cover basically. The syllabus, what chapter are we covering? I'm going to check my syllabus again. Yeah, I didn't put chapter 20 on there. I'm almost done with chapter 19, so I'm throwing in review now. We're doing review. We've got chapter.
Like 3 weeks, the next 2 weeks.
Kinda, but it's not like a general broad overview. We're just doing, like for example, yesterday we looked back at Bronsted acid base, and then threw in equilibrium, Le Chatelier's principle, and metathesis. Today we're going redox, metathesis, that's it, and then some other concepts that we covered recently and concepts we covered in the past. So this is your nomenclature review right now.
Are we doing a lab on Thursday?
We are doing a lab on Thursday.
Are we collecting labs on Thursday?
Yeah, let's like the lab. Bring, that's right, I forgot to make an announcement. Bring your experiment 10. We're going to finish up that titration. But some of the other labs will collect on the last day.
Are you assigning homework this term?
Yeah, I'm going to assign homework for these chapters too. But try to keep it short because next week we have the exam 4, and the week after we have the final exam.
The week after? We just skip this last test? I think we should skip this exam and then that'll be a time review for the final.
We have a week to review for the final. I know, that's why I'm trying to avoid covering new material last week. 8. That's why I come blasted through 16, 17, 18.
Do you think it's fair if you ask for the homework that you're gonna do like by tomorrow, Thursday, so we can start over the weekend, so we have time to review for the final and the test?
What was that? The homework on Thursday?
Can we get the homework that you are gonna assign the homework, correct?
Oh yeah. I'm gonna assign it this week.
Okay.
Yeah, you'll get all. Yeah, it's a lot. If there's specific stuff you want me to review, we can review it as well. But we're just doing little bits here and there, like, for example, nomenclature, polyatomic ion, fixed charge, variable charge, oxidation state, this kind of stuff. Here and there.
So what are you gonna assign the homework? Because I'm not sure if you reach out to me.
Oh, I'm going to assign the homework. What was the last homework I assigned? Chapter 15. I'm going to assign the homework. The homework assignments are going to be shorter, not 40 questions each. More like 39 questions. Anyway. So this is going to be our oxidizing agent. We figured it out. It's not going to be the nitrate. Nitrate's going to be a spectator, our oxidizing agent. And this reaction is called reduction or oxidation. Reduction. So our oxidizing agent oxidizes something. When it oxidizes something, it becomes reduced in the process. It gains electrons. Rig, oil rig. Oxidation is loss. Reduction is gain. This is good. The anode and the cathode, left to right. Electrons going left to right. What is this called? This should be connected, by the way, because you can't just sprinkle potassium ions on this side. It has to be together, right? And this is called the salt bridge, and it's going to be K2SO4. The salt bridge, what are the requirements? Well, it could be any salt. Well, let me qualify that. It can't be any salt. The salt bridge has to be an unreactive salt. Potassium sulfate's not good. Do you know why it's not good? Yes. It's not good because, yes, potassium ions should only go this way, and sulfate ions should only go that way, but sometimes there's diffusion processes occurring. And so some potassium sulfate might leak into this beaker, and some potassium sulfate could leak into this beaker, right? And so the potassium sulfate, if it leaks into this beaker, well, potassium ions aren't going to do anything, but what about sulfate ions? If sulfate were to happen to leak into this beaker, could it cause trouble? Yes. And the trouble is due to metathesis. What do you know about sulfate and metathesis? What ions does sulfate like? Silver. Sulfates are all soluble except for silver. So silver sulfate will precipitate. Well, if silver sulfate precipitates, then who's gonna attack the electrode, the cathode for electrons? And so that's a problem because we don't want silver to be tied up because we want silver to attack the cathode. We don't want silver to attack the sulfate or the sulfate to attack the silver. Right? And so we cannot use, potassium is okay, but we should not use sulfate. We should use something else that's unreactive. Well, tell me something else that might work. Chloride? Chlorine? Chlorate?
Yeah.
There's a problem with chlorate. What do you know about chlorate? You might have seen something on the chart. This is extending your knowledge. If you can think about extending it here. You might have seen something on the chart. You recognize this one? What's that called? This is iodate. What do you think? Chlorate's more powerful or less powerful than iodate? Well, let's compare iodine, I2, with chlorine, Cl2. Which one wants electrons? Which one's thirstier for electrons? I like that, thirstier for electrons. Chlorine or iodine? Chlorine. Which one do you think would be thirstier? Iodate or chlorate? I would not use chlorate because, you know, chlorate is even more powerful. Look at, nitrate's more powerful than silver ions. Iodate's more powerful than nitrate. Chlorate's more powerful than iodate. That's what I would expect. This would be the, you know, if you want like the top score in the class, these are the types of things you would do. You know, you think about these things like this. That way you can extend your knowledge rather than organize it. Whatever. So chlorate, well, obviously we're missing the H+, but still, it's probably not a good idea to put another powerful oxidizer in there. We probably should use something like chloride. Is chloride a good oxidizer? No, chloride's not even on the oxidizer side. There's no chloride over here. And so there's going to be no competition, right? And so let's use potassium chloride. If I use potassium chloride, then I don't have to worry about chloride trying to compete for electrons, right? And so would potassium chloride be a good alternative for the salt bridge? Would potassium chloride work for the salt bridge? Yes? No, it would be bad. It would be bad not because of chloride competing for electrons, because chloride's not going to compete for electrons. It would be bad because chloride would attack what? Well, chlorides are all soluble except for silver. So chloride's going to attack silver ions and precipitate silver chloride. Chloride ions attack silver ions, then there are going to be fewer silver ions to attack the electrode to pull the electrons. You're going to destroy your battery. And so potassium chloride's not good. Give me another salt. So potassium sulfate's bad. Potassium chloride is bad. I need another salt. But I'm in no danger of running out of salts, because what are salts? Salts are ionic compounds that are not acids. How many ionic compounds are there? Lots. Lots and lots of ionic compounds. So just give me another ionic compound. We'll try it. Carbonate? Carbonates are all insoluble except for group 1 and ammonium. Other than that, carbonates will precipitate out with everything. So what we're going to do is we're going to get a blue PPT of copper 2 carbonate over here, and over here we're going to get a white PPT of silver carbonate. The carbonate's not good. We need something that's unreactive in metathesis. What's the least reactive anions? Or what are the least reactive anions you can think of? Ones that don't precipitate out with much. Can you recite the solubility rules? Somebody recite the solubility rules for me? This is part of your review. Hopefully Hopefully you aren't cramming all this the night before the final. Otherwise, it's gonna be like a tidal wave. What are the solubility rules? Maybe I should have started the review earlier. Too late. Well, no. Actually, you should be reviewing every day, or every other day, or every week. You know, at least. Just go through your notes from day one, or the book, or whatever you use to study. Nobody can recite the solubility rules? Close? Group 1 and ammonium are all soluble. So let's start there. That's one. Okay, somebody else take. Okay, group 1 and ammonium are all soluble.
Chlorine? Chlorine? Like it's soluble, but like there's like exceptions?
Yeah. Chlorides, bromides, and iodides. But before we get to chlorides, bromides, and iodides, there's one before that. What was the one before that? Well, one of them was mentioned, chlorates. Chlorates are all soluble, pretty much. Chlorates, nitrates, and acetates are all soluble. So those are actually the least reactive. So chlorate was very good. Chlorate was a very good choice. However, the only problem with chlorate is it's a strong oxidizer. So we got to watch out for that. Even though we don't have the H+, we got to watch out, because if we get a high enough concentration, something might happen. So we can use nitrate, or we can use acetate. So if we use potassium nitrate, then it's okay. I mean, we already got nitrate here. And, we don't have the H+, so we're just adding a little more nitrate. And so potassium nitrate works. Okay, so if some nitrate leaks over here, then we got a little bit more nitrate. But the nitrate can go this way. Or we could use acetate. Now, as far as acetate goes, what is acetate? An oxidizer or reducer? Could you tell? A long time ago I asked this. Can you burn acetate? Does acetate burn? What do you think? If I have potassium acetate, could you burn it? Like potassium chloride. Could you burn potassium chloride? No. You really couldn't burn it, because chloride really holds on to its electron. It's not a good fuel. No. Can you burn steel wool? Does steel wool burn?
Yeah.
Steel wool burns. Iron. Metals are electron rich. Can you burn acetate? So, for example, one place you see acetates in vinegar. Is vinegar calorie-less? Does vinegar have 0 joules? So when you eat vinegar, you get no energy? You can't burn it? Or does vinegar have calories? Not many, but does vinegar have calories? Yes. You know what that means? It means you can burn it. Your body burns it as fuel. You eat vinegar, you exhale CO2, water, and you get energy. And so we also have to not just metathesis reactions, but we also have to worry about redox properties when we select the salt bridge. And so acetate can go either way. It's an oxidizer or a reducer. It's not very strong. It's not a great fuel, so it'll probably be okay. Nitrate is a good oxidizer. So if it comes down to potassium acetate versus potassium nitrate, either one, you know, it's got to trade off. But as far as metathesis goes, that's it. Okay, well, let's take a break now, and we'll start again.
Do you guys remember that
We're going to have a little longer break than usual. I just have to take care of emergency.
Alright, bye guys. Go.
Yeah, oh, but she's but it's not gonna play. It'll just go with that. Dude, I was walking. I parked on the little thing. I was walking upstairs. Just look at the dead pigeon right there. Oh, I just was first time I see it. Yes, dead pigeon. There was a dead pigeon, and then there was one that was like standing next to it. She was like looking at us.
Oh my god.
Well, it's like, how did the pigeon get ran over? It can't just fly away. It's just stupid. It's just like, you're right there.
Oh, I watched the one where they're just using training a wrestler. He's getting his ass kicked.
Was he like so heavy or something?
Oh yes, he's like took a shit right It's like floors. And at the end when he was having his final battle, like he took the life force out of the guy he was training, and then like I was like, oh my. There was like one floor like that. Oh yeah, there's almost like a CEO. She was like not match day. She like hated things. Yeah, I think I started spam watching other ones like the Odyssey. Yeah, those are, I think those are like the best of that.
Oh,
The
he's got
best
the
ones.
specs are so excavated for CO2 page freaking editors.
Have you actually seen it?
No, wait, is that actual person?
Yeah, there's that actual like YouTuber and cusses that. So it's like.
Oh, you did so close. Actually, you're right. This antler's probably bad. It's normal.
What you just saw?
Totally knocked out, dude. It's so good.
Like chicken, it was like 16 chickens. It seems like everyone is just raging. Put the chicken in the sink. Yeah, that's what he was doing. Really.
That was probably why he had like the people like some people like watch him and they do it right or like live or something.
It's just like, but it's just like comments.
Because I thought that's what like you know how like in the beginning of he had like a live chat there.
Oh yeah.
And they like everybody left because they're like like started like logging on to the chat.
I don't know if they did like videos. I don't know if she was
She's like cussing at the guy.
I think it's so bad off my screen. I don't want to see some like crazy possession going on. What the hell, bro? This is. Bro, you're fucking possessed. I don't want to watch this. I don't want to watch this ad. It's like weird. Sorry, dude. You're gonna. I don't watch the goddamn possession. Alright. You're a red hot pipe and you're just gonna
Apparently, like there's this girl like a long time. There's a movie thing on this.
Yeah, let's see it.
Girl, like showing it's this like yard sale and she bought this box. They're gonna do the box and it's gonna like competition possessed stuff. And then like she opened it and got possessed. And they made a movie of like story. True story. She opens the box. What are you doing?
Yeah. It's like a tumor. It's a true story.
some of them answer to this question.
Oh, dude, I didn't know what was happening. I read yesterday. It's not that bad. There's no other ones that are like I can actually touch it. There's only one table. Now when I can reach it later, it's gonna be like weird looking uphill.
So you can do, like,
What? That makes it more of a dream, so I can't do plays. I can do plays either on Monday, like yesterday, because I usually do them.
because you did it,
But I can just slide in from so I know that actually Monday, Thursday, Friday, I can do this. But every other day I just because I think my legs
I don't know what how to do I'm just gonna figure it out. When I'm not
they have so many good desks. That's how I do it. It's like my body.
Yeah, I saw this. This is these was like I have to see that shit.
What
It really rages in
a
series.
What a series he back.
I don't know. Actually, one time, like when I was really young, like I just like, I was like, seriously, something stupid. My mom got mad. I was going to serious. I was like, you won't do that, you're gonna hurt his feelings. I was like, wait, what's she talking about? She's like, she was serious too. I was like, what is she talking about?
Mom.
Serious. I wanna cuss out Siri. As hard as I can. Like, go like
Wait, isn't there a movie on like someone loving Siri?
Is there?
I think so. Wait. There is a movie. I think it's called Her.
Look, he reminds me that we've never put their names on separately or what does he do that? You know why? It's because they don't buy it regardless if it's on Saturday.
Dude, when I
I hate myself because I know we'll do it again.
no, I just go my age. Just get out. I was never because I didn't feel like those ages. Yeah, well now it makes it. I don't think we can change it back. It's still like an age. Like 20.
Yeah, it's happened today, dude.
Actually, it's a big app.
I watched a documentary on the You know, he was a marine biologist before he that's writing system. What's called sea sludge on it. That's sad. Dude, he's gonna be a big rep for the voice actor for Star Trek. Oh, he did a. He was a voice. Oh yeah, wait, I remember the show. I forgot what his name was. That's Chick-fil-A is so good.
Wait, is someone behind the trees?
Yeah, wait, what?
I would have thought, you know, I would have just pulled back in
Wait, yeah, I just don't know what he said.
I still need to
Because my favorite is serious. What's you for cereal?
Either way, I'd still be
What's happening?
I was about to say that. I was like, you're waiting.
I have to come early. I'm like,
There's just that
it's not good. I guess.
Why do they need that age restriction?
I don't know. Or because they don't have kids on the road. We can't show this.
And Thursday, I get my final for It's 7 to 2. It's
Have you seen India's
there's a lot of
Postmate advertisement?
Wait, what? She is an advertisement?
Oh,
Oh my, dude, my friend was doing Postmates and he was like, it takes like 10 years to get to your door. You're like, they don't pay you that much. Pretty much, like, I didn't even, you have to like, pay gas money.
But luckily the last, this is last essay is about watching.
It takes so long, you have to wait to make an order, and on top of that, when you go there, if they didn't place an order at that place, you have to wait there for the social commentary.
What does Postmate show?
And it takes long, like,
I don't know, because I guess. Supposedly it's not.
I was actually following it.
I know people
You
do that.
follow it?
Yeah.
Yeah. Yeah, there's like cars that are supposed to.
You're not supposed to take you in trouble. Yeah, if you do both.
The names of the stickers. I see a bunch of cars of that.
I know. Actually, they might have changed it, but I know when they first started, the Lyft drivers did not want you. I didn't watch it. But I know what they might have changed it. That's what I'm saying. They didn't want you to. I'm sure they didn't stop. So maybe they changed the policy. You gotta hustle. The hustle through.
Well, yeah,
That's why Uber Eats. Oh, but I'm also a Lyft
Well, they probably don't want you to do that because
I think they
I'm sure like your quality might be bad. Oh, I'm taking this guy and this guy. Or I'm gonna be late to the other.
It's like you saw me thinking it's not supposed to go past this point. It's just not that. It's not supposed to do that though. It's weird. Yeah, it's supposed to see around you. I did it really hard. It flew back down his face. And then this entire it was off. Like I think you did the wall. And like yeah, then you just took out. It's like
They might send me to another room.
everyone always like point out like the silver and like the gold. Yeah, you're signing like the
instead of like
wait, what? Yeah.
I think we all would drop their jobs to be here.
Yeah, just sure you're gonna. Yeah. I just heard something. I didn't mean
maybe because I'm using like the past.
Like if he doesn't collect it,
Maybe he was
time
saying buskets.
Just gonna get on my loud
I mean, Cody cusses a lot.
Bullshit.
Who's that one guy? I don't know, like,
Talking up from the book.
like, in Creepy's like, there's that one character that comes in, like, fuck, go on.
I was listening to an audiobook.
Oh, yeah.
I was like, we got to go to the we were supposed to leave.
The guy says, like, look like, and I agree,
Oh my god. Do your best. No, I can't. Can't register until my track gets there.
Wait, what?
So till this semester.
Wait, flat out?
I'm going to.
It's gonna be on. Oh, wait, you're. That's good. So, yeah, we are.
You're taking it like
An hour, yeah. It's kind of like. Thursday. Like that. Yeah. Probably for that second afternoon.
That's the name.
he'll be considered he's making his video might be on
Yeah, oh yeah, it's gonna be on the stuff. And like, I hated it.
It's weird, man. You know, it's real weird. I feel like motorcycles are a lot easier to learn.
They were doing what they get, I understand. It's just learning from us.
Your drifter, bro?
You guys have a
Like every car has like one straight in the back, but the issue car has one in the back and two out front. Because you can also go like a little deeper to the turn with your brake because you downshift like downshift hold you tight. So like your father is going to do like two.
how much
But I don't remember. I don't know if you
what are you taking?
So, brain is taking a little bit.
Like, I was trying to like one time to make sure just way too much money to a good car. Like, I got the straightway, the spurt, and was kind of like kicked me off the track, where I freaking flew over the barrier. And my like entire car, like the chassis, the chassis or chassis, I don't get that. Yeah, we had to get a new one of those. And the engine was like leaking too.
Are you talking about the phone?
There's no, they don't have something. There's no snow.
Well, what?
They were like snug. But I actually, when I got hit, I was like halfway on my seat. Like, I was like sitting like this is the seat. I was like up on it. I was like, it was so much worse.
Oh, yeah, that's fun.
I couldn't tell what was happening. Yeah,
Is it like when the line is where you just go straight?
no, not that.
I'm saying, actually, maybe it's like, you know, family members, it's like, that's a great guy.
Yeah, I feel
Hey, that's the fastest for sure.
Also, it's like a restaurant.
Your intestines get neat for sure.
No, but he's going like he had the keys to the cars.
I know more than one person is fast. It's fast tracks.
Then again, it's like,
Yeah, the whole thing is about trying to go fast. It's not easy.
why do you think he's talking to
You put a trade on it.
Same thing, everything goes from upside down. You go fast and things that just ground more. So that's
Because like,
It's not only that,
he's
too.
on a business.
It's pointed
like the whole.
where the wheels in the back are really fat, but the wheels in the front are like pointing right straight. I don't know if they're pointing like
I don't think he's the type of guy to go
yeah, so the wheels here, those are small and I'm walking around
Okay, sorry.
Didn't you see that
All right. So chapter 19, the first part of chapter 19 is the application of redox to batteries. The second part is just talking about redox reactions. And so 19.1 battery electrochemical cell. And then we have the other type of cell. Do you know what the other type of cell is called? the electrolytic cell. The voltaic cell is going to generate electricity. This generates 1.1 volts, but eventually that's going to die, and it's going to go to 0 volts of potential. Oops, I forgot to turn